No, my project's not done.
I think we're ready. We might be ready.
Yeah, but my...
This is this is project number 1. So the first thing we're going to need is a MicroLogic 1000. And we're going to need it powered up. And we're going to need a communications cable hooked into it going to our computer. The second thing we're going to need is to be in RS Logic, in RS Link, the communication language for the machine. I thought I was going to increase the size, but I didn't. Oh, there we go. I can hit here to increase the size. Okay, so now we're coming up in RS Link. And we did that by going into RS Software. And there's a squiggly line in the middle on top. See the squiggly line in the middle on top?
RS links right there.
Yes, there's RS Link, and we want RS Link Classic if that's what we have, but this RS Link would work. Okay, there's a squiggly line on top. Higher, 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 higher. Yeah, right there. Now, we need a driver, so... No, look and see what driver is running right now. What driver does it say is running?
The correct one?
No, that's the wrong one. What's running is some emulator driver, and we're not close enough to see it. So let's see if we can get our camera in close enough so we can actually see what we're looking at, and the answer is no, we can't. Because our angle's bad. Why don't we go, what we're going to do, it's going to cause a little bit of a problem, but we're going to make the legs a little shorter. So we can get down to where we want to be. Okay, that looks better. So anyway, right now, the driver that we want, that's there is the wrong one, so we got to get rid of it. So click on the driver that's running. Click on that guy. Boom. Hit stop. And then hit delete. All right, so we got rid of the driver we don't want. We want the driver that talks to the RS-232 port. So RS-232 DF1 drivers is the guy we want.
That says
because
devices.
we're coming from devices. Because we're coming through the RS-232 port, and we clicked Add, we clicked there. Now, this is where we have to set up the communications. So right now, we COM port 1's correct, that's correct, but this is not a PLC channel 0. This is a MicroLogic, this is an SLC channel 0 MicroLogic panel view. So we're going to click on that guy. Now we're going to do an auto configure, and what it's going to do is it's going to interrogate the machine to see at what speed it can talk to it at. Right now we seem to be having some interesting problem, and it says we're unable to verify the settings due to the fact that we timed out. Alright, so that's not good. And this guy's in run, and this guy, okay, so we're going to do it again, but we're going to drop the baud rate. So drop the baud rate down to 9600, click, and then try it again. And right now it's saying auto configuration successful. What that means is that we are now talking to the unit. So we can say OK. OK. We can close. If we come up to there, we can, and we click on our DF1 network, we see that we have our computer at channel 0 and our MicroLogic is at channel 1. The computer is always going to be channel 0. The DF1 connection is always channel 1. Okay, so that's just the way that is. Now, this program has to be running in the background, so we're going to minimize that, and now it's going to be running. Okay, so now we have communications set up, but we don't have the program written yet, is what I'm being told. Is that what I'm being told?
It's wrote, it's just not
We're gonna
complete.
Maximize the whole thing and get the program complete. We'll watch you while you do that. Keep
I don't know what I'm missing.
Keep the
So,
video going while we're doing that.
do you know what I'm missing?
No, I don't know what you're missing. But I do know that don't have much there. Now, do you have the instructions for this guy?
Yes.
All right, so that would be a
Grabbing
good
them.
thing to have. So, input 1. I'm making the picture bigger. So input 1 turns on 1, and input 0 is 0, and 1 is 1, and 2 is 4, and 3 is 6, 4 is 7, 5 is 11, 12 is 6. So all that is correct. And then when we hit input 7, and let's back off just a little bit. When we hit input 7, we're going to start a timer. Now, we didn't bother to label the timer, so we're going to come back. I just did a right mouse click. I'm hitting edit description. Type in 1 second timer. Okay. So now that's a 1 second timer, preset of 1. A 2 is supposed to be coming on. When that timer is done, we're supposed to turn on a 5, and we do. We need to edit the description on this guy, call him 2 second timer. Notice that when we label the timer, we've also labeled the done bit associated with the timer. So now we have the 2 second timer comes on, and when the 2 second timer is done, we're supposed to see a 7. So we'll rearrange our self down here and come up with output 7, and then we'll describe that as, it's already described as output 7, not a problem. And now we're going to want to put a jumper in and a timer, and the timer we want to call is T4:2, so we'll go with T4:2,
Wait, you just...
colon 2. Oh yeah, I can click on it. Okay, what we'll do is we'll just put in a T. And because this is what it is, okay, this is a 4 second timer. If this were the software in L124, which is the free software, we couldn't have done what we just did. And we didn't do it very effectively anyway. T4:2. T4, stop, enter, boom, boom. All right, there we go. So this is a 4 second timer, and time base, we'll change the time base to 100, and we'll change it to 4. Darn, got the wrong one. T.
Yep.
Right, that's the one we want. No, that's not the one we want. Yeah, that's one. Okay, everything's fine. All right, now we're here, 400.
What?
Now we have a 4 second timer.
Why did you do that?
Do what?
Take the time base down to
Because I can't.
hundreds. Okay.
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 Because why do the same thing over and over again the same way? That doesn't make any sense, right? So we can use a hundredths time base. Now we can't use the thousandth. It says we have a thousandth one, but in the MicroLogic 1000, there isn't such a thing. So that would come up as an error. All right, so where are we? That's the 4 second timer. Now we want one more. So we want this timer done bit. We'll bring in my timers again. And I got the wrong bit. I got the wrong guy. We're doing a delete of that instruction. Okay, so we want the T4:3 done bit, so we'll grab that guy. No, we want the :2 done bit. :2 done bit. Alright, so now T4:2 is done. We want something to come on. What do we want to come on?
An 8.
3. After the 4-second timer,
Oh.
we want a 3 to come on. Right, so we'll grab the 3. And we'll give that a description, output 3, if you'd be so kind. That's good enough. You don't have to spell right. Alright, so that's output 3. We need a jumper. And we need a timer. And what we're going to do is type in a T and then hit the enter button. Enter, 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 enter. Enter. Okay, that brings up the next timer. We need to describe it. 8-second timer. Okay, so we'll do the same thing. It's more fun having hundredths of a second show up than having whole seconds show up because it just takes too long for a whole second to show up. And then we need one more run. And we need a T3:done bit. T3:done, and then an 8 is going to show up. Now, the way that this program's written, it's not going to work. It's designed to not work on purpose and for us to correct it. So we're going to run it first and see what it does. Edit description, output 8, please. And the green check marks up here checks it. That also compiles the program. So it does both things. We need to assign a driver. Right now our driver is unknown. So we come up in Communication Properties, Controller Communications, and we pick a driver from the massive list of drivers that are there. Normally we get a choice. It's going to be node 1, and we saw that it was node 1 when we looked at the RS Link guide. We hit the apply button, we say OK. In RS Logic 500, if you have an apply button, use it. You could say OK and hope for the best, but I'd rather not. Now, because we've already established communications in RS Link, we should be able to just do a download. And so we're going to do a download. This is a revision note we can put in. So put in a revision note. My instructor is awesome. Would be a perfectly legitimate revision note. Oh yes, even spelled right. Okay. So now we're downloading from we're going to the MicroLogic slave on node 1. Okay, so all that's right. And we're in run, so we had to come out of run. Did that for us. This is an EEPROM we're writing to. All right, now we're back to online and we're back in run. So we're in run, and we're going to make the outputs a little bigger so we have a chance of seeing them in the picture that we're doing. Think that's big enough? All right, well, that looks relatively big enough. In fact, it's probably too big because it only goes up to 8. We're going to also want to look at the timer when it does things, so we'll keep that going.
I zoomed it in a little bit so you could actually see the computer screen.
Oh, excellent. Excellent, excellent. Okay, well, it looks like we're all set, ready to go. Okay, now, in the emulator, what we would do is we would go and do a toggle. So I'd go here and I'd toggle the bit. Now, if I toggle the bit when I'm using the real hardware, it's not gonna do anything. What it did is it toggled the bit for one program scan. One program scan is probably 10,000th of a second with this program. So that means we had no chance of seeing anything come on. So if you remember how the processor works, we do an input scan, we do a program scan, we do an output scan. So if I toggle the bit, it's going to stay toggled until the input scan happens, and then it's going to go and look at the hardwired inputs and say they're all 0 and 0 it out. So I can't do that. But what I can do is I can force the input on. So I force the input on, my output 0 is on, and I see on my processor that my output 0 is on. Can I see that?
Yeah.
Okay, so then I can see that it's
Bring it a
on,
little closer.
and I can see that it's
Right there.
I can see that it's forced. I can see that I'm in run, and I can see that I have power. Those are all things that I can see. All right, so now we're going to go and do the same thing, and you may have heard the click, because this is a relay system, so you may have heard the click. I'm going to turn on, force on input 1, and see if we can hear the click. So we heard the click. Whether or not the video heard the click or not, that's a different issue. So now input 1's on. I'm showing that the output's on. I'm now going to force input 2. Now there's a 4 on.
Yep, we have 4 on.
I'm going to force input 3. The 6 is on. I'm going to force input 4. The 7 is not on. So I forced input 4. The computer is saying that input 4 is on, but input 7 is not on. So that's an issue. We're going to have to correct that. We go to 5, and we force on 5, and we see 11. And then we're going to force on 6, and we see 12. All right, we forced on 6, but we didn't see a 12. Where's the 12?
Because we don't have a 12
Okay,
light.
so the 12 output is a virtual output. It's not a output that can be used by the output device, but I can still use that bit if I wanted to in my programming. Okay, now I'm going to go, and up on top here, I'm going to remove all my forces so I don't have to go back and do it individually. So I've removed all my forces. Now I'm going to go and turn on 7, and what we're going to do is, when I do that, we're going to see our timer working. Are we ready? Okay, so the 2's on, second
5
later
is
the
on.
5's on, 2
7
seconds later 7. 4 seconds later the
3.
3 comes on, and then the last guy that comes on is the 8 after 8 seconds. Okay,
Yep.
so there's the 8 after 8 seconds.
So that
So
works.
the timer guys are working fine, and notice that output 7 came on that time, but output 7 did not come on the time before. Now, why is this? Well,
Because they're both. Something's linked between them.
because the rule says that for my output thing, it can only be in one run. I have output 7 in 2 runs, in run 4 and 9. The program is a sequential program. When it gets down to run 4 and turns on output 7, okay, that's fine. It gets down to run 9 and going to turn it off. Now it's off. After I get to the end run of the program and I'm done running the program, then I write to my outputs. What do I write to my output? Well, I write out a 0. It's not on. So what I need to do is the logic that turns on an output, all that logic has to be on one run. So what we'll do is we'll come offline and we'll change that situation. And so we're going to change that situation. And we come down to where output 7 is the second time. And we see that we can't have him there. So we're gonna cut him out of there. We're going to move our timer up. If I were to hit the delete button right now, I'm going to go ahead and hit the delete button. I deleted too much. I didn't want to do that. Luckily, I got a go back button, so I'm going to go back. So when you delete a jumper, you need to move the jumper. Now hit the delete button. You need to move the jumper so you don't delete everything else above it. That's just one of those things. I notice that this is time T4:1 done bit. So I go back up to the run where number 7 is, and I put a jumper around input 4, and I type T4:1/DN. T4:1/done, DN. Enter. And I don't have to describe it, it's already described. I don't have to do it again. All right, so now I've changed my program. I'm going to download that program. This one's good. It would be a good revision though. Well, you don't know it works yet because we haven't run it.
I know it's gonna work.
You know it's going to work. So the only thing we want to see is that timer, that output 7 comes on. Okay, I'm going back to run. That output 7 comes on.
Yep.
And it does. And I changed one other thing, which is the timer sequence. So we'll start the timer sequence. And
2 through 5.
2's on, 5's
7.
on, 7's on. Coming
3.
up on 3. And coming up on 8. Only 3 seconds to go.
Yep.
And now 8's on. All right, so that's the end of the project number 1. The only other thing we need to do is what, I wonder? Oh, I know what we need to do. We're gonna come offline, and we're gonna do a save, and then we're gonna go and look at. We're gonna do an open, and this is where the project is. And notice there's project 1, and there's backup 2, 3, and 4. So I go home and I come back tomorrow. Which of these am I opening up? Project 1, backup 2, 3, or 4. So that's the issue. And the issue is we never open a backup. A backup is always older than the last thing I saved. The last thing I saved doesn't say backup. Okay? So that's the way that is. But if we wanted an older program that was wrong, we could open one of those other guys. Okay? And that ends project 1.